How we doing? Devin, Clarke coming to you again from Yara's Incubator Farm in Modesto, California. So it's the middle of May right now. We're holed up in the shade a little bit as it's getting rather warm. We're going to be staring down some 100-degree temperatures here in the next week. And with that comes heat stress that can be induced into our crops, into our trees, and it has very negative impacts on the potential for this year's crop, as well as the developing crop for next year. And so I wanted to touch bases with you a little bit on how we can better understand what this heat stress does internally to the plant, what it means as far as the potential for this year's crop is, as well as the formation of next year's crop, and then also what we can do from a nutritional standpoint to help mitigate that. So for starters, understanding what physiological responses take place in the tree when experiencing, we'll just say, heat stress or drought stress. They can be used simultaneously in a lot of cases. And what happens is that plant senses and experiences heat stress or drought stress, and it creates these reactive oxygen species. Now, these reactive oxygen species are compounds developed in the plant that can really act to kind of sacrifice some plant tissues for the sake of the greater good or the sake of the greater the tree itself. So it will actually damage RNA, it'll damage DNA, it'll damage proteins, they will damage plant cell membranes as well. And so we have basically a loss and a degradation of tissue, tissue death that occurs at that point. And so what happens from there is that you have less ability to photosynthesize, you have less ability to be able to produce and store carbohydrates, and so you've reduced your potential for next year, in addition to the damage of the protein and cell membranes that occurred in this year's cropping season. So with that being said, nutritionally, the element that we really want to focus on in this argument is looking at calcium. And so calcium can help the tree mitigate this stress in really two very fundamental ways. And the first of those being that the calcium itself is implicated in the direct reduction of forming reactive oxygen species. So calcium will actually inhibit the formation of these reactive oxygen species that then damage plant tissues. So directly involved there, and then indirectly, calcium is also very heavily utilized for the pumping of potassium ions into guard cells. Now, guard cells are on the underside of the leaves, and they are cavities that open and close basically to exchange water vapor, and that's part of the entire transpiration stream that the trees experience. So when we have calcium in an adequate supply along with potassium, that calcium can help supply potassium to those guard cells so that they can function properly. The tree then can move water through itself, let it escape as water vapor through these guard cells and the stomates. And when that happens, that process creates a cooling effect for the tree, very similar to the way humans sweat. And when humans sweat, that moisture that is created on the surface of the skin or generated to the surface, when it evaporates, that similarly has a cooling effect on the human body. So very much like humans, plants need to cool themselves as well. They do that by regulating these guard cells, and those guard cells are assisted by calcium supplying them adequate levels of potassium ions. So anyway, with that being said, as we do move to this time frame of probably putting our last application of nitrogen on, I want you to be aware of the value of Yara Levacan 17 and CN9 in this late application, and its ability to provide 100% soluble calcium to the plant that is immediately taken up and is able to be utilized for this purpose of mitigating heat stress as we described today. Thank you very much, and we'll catch up with you next time.